Hello, dear students. This is your Jagan sir. Welcome back to our physics. Welcome back to our YouTube channel, Physics with Jagan sir. And today we are going to discuss Newton's laws of motion, second class. And this second class, let us first see what is Newton's third law of motion. Newton's third law of motion. In Newton's third law of motion, we know that for every action, equal and opposite reaction is existing. That means here a ball, here a ball is present. A ball is present. Suppose a ball having some amount of velocity, and if it is touching the wall with some amount of force, that means if it is exerting certain amount of force on the wall will also exert the equal and same magnitude force but in the opposite direction. This is the force on ball by wall, and this is the force on ball by the ball, and here force on ball by the ball is equals to force on ball by the ball. So the magnitude remains the same, but these are representing in the opposite direction. These are representing in the opposite direction. Right? For your clarity, let us have a small example. A man A of mass A is equals to 60 kg pushes the other man B of mass 75 kg 75 kg, due to which man B starts moving with an acceleration of he is moving with an acceleration of 3 meter per second square. 3 meter per second square. Calculate the acceleration of man A at that instant. So force exerting on A by B is equals to force exerting on B by A. Magnitude wise, these two are equal, but in the opposite direction, as I told you. So here, force is equals to M A, acceleration of A, M A B, acceleration of B. Now, mass is equals to 60, his acceleration which I am going to find, and mass is equals to 75, acceleration is 3. These are the conceptual questions. Even sometimes they make us to confuse. So to avoid that confusion, I am explaining first of all how to get the confidence on the concept. Then I am applying the same concept on numericals to make you to be comfortable. And this one 15 4 15 5, then A is equals to 15 by 4 meter per second square. 15 by 4 meter per second square, right? And this is the first topic, and let us go for the second one, free body diagrams. Free body diagrams. What are the free body diagrams? Free body diagram means, see, representation of set of forces acting on an object. Representation of set of forces acting on the object. Representation of, and force is actually vector. So representation of force vector, representation of set of force vectors acting on the body is known as free body diagrams. Free body diagrams, right? Free body diagrams, right? Then next one is, let us see some set of forces acting or representing on the questions. How we can represent these set of forces acting on the system. Number one is weight. How can I represent weight vector? Weight is actually force only. And how can we represent this weight vector? See here, first point is, this is the earth. Earth will always attract every object towards its center. Towards its center. Suppose here a candidate with a mass m is present, and this person is attracting towards the center of the earth with the acceleration due to gravity g, magnitude only I am writing. So his weight is equals to mg. Mg. Otherwise sometimes we represent with the letter w, right? Here you must understand one point here. This vector is always representing in the downward direction. This weight vector is always representing towards the center of the earth. Clear my point? Then the second one is normal force. This is one of the important representation, normal force. Normal force means where is the contact existing between two surfaces, there you will get a force, that is normal force. Suppose here a block is existing, let us say block, this is ground G, right? Here the contact is existing between these two surfaces, block A surface and ground surface. Now here we will get a force, normal force on A block due to gravity, sorry, due to ground. This is normal force on A due to G, and similarly this is normal force GA, that is normal force on ground due to A, due to A. So you must remember that these are actually equal and opposite forces, and here the magnitude of these two forces remains same. The magnitude of these two forces remains same, right? Suppose we have a system like this. Suppose we have a system like this, and here for this system, suppose a object is existing like this. So this tip is exerting normal force, one normal force. This ground is exerting one normal force. So you must remember here, you must remember here for every contact one normal force will exert, for every contact one normal force will exert, and here one contact is present due to tip, here one contact is exert due to ground, right? Now this is due to n1, this is due to n2. Clear? Now here again let us assume one more case. Here contact is existing between these two, normal force is existing, and here a contact is existing, so normal force is again existing. So you have to remember that where is the contact is existing, there should be normal force will exert. This is what is about normal force. And number third is tensional force or tension force. Tension force. Remember, considering a tension force is one of the most important concept here, because see very carefully here. This is most important because so many of the students are getting confusion in understanding the way in which direction the tension has to be representing. This is most important. So tension, as I told you in our previous class, tension is the force which is exerting in the thread, in the rope, right? And this tension is always represents away from the point of contact. So here most important note is tension should represent always away from point of contact. This is one of the most important concept, because because most of the students are getting confusion here in which direction I have to represent T. Now here tension on block is T. Suppose the block is moving with an acceleration T A, so because of this force the object is attaining an acceleration, mass of the object is m, so ma is the force, so that tension is converting into force to the object. Clear? This is how we represent a tensional force. And next one is frictional force, and you will get the clarity in representation of these forces in our upcoming class and upcoming classes also, because we are going to discuss so many numericals. In every numerical I definitely represent in which direction we are considering different types of forces, there you will get the clarity, so that will helps you a lot. Now frictional force means here a object is present, a ground is present, a surface is present, and whenever certain amount of force is acting on this block, whenever certain amount of force is acting on the block will tries to oppose the force and tries to oppose the force. There is a set of forces present, there is a type of force is present. That force will oppose the relative velocity or relative separation, relative motion between the ground and object. Ground and object. That force is opposing the relative motion between the ground and object. That force is known as frictional force. So what is the frictional force work? Frictional force is trying to oppose the relative motion between the two objects, right? And we have two different types of frictional forces, kinetic frictional force and static frictional force. When the time arises, we will definitely explain, I will definitely explain in detail about the frictional force. Clear? And next one is elastic spring force. Elastic spring force. Elastic spring force means here a spring is present. This spring, if we, the mass I am pulling with certain amount of force in the rightward direction, and whenever I am removing that force, external force, the spring tries to pull the object towards its mean position. Mean position means its original position. Let us assume its original position. The spring will try to pull the object towards its original position, right? And this force, the spring applies some amount of force. That force is known as spring, elastic spring force. So elastic spring force direction is opposite to the direction of force I am applying. So this is what is elastic spring force. I hope these are the different types of forces acting on the object. Now based on this type of forces, let us see. Chalo, before that, let us see what is the equilibrium of a particle. Suppose here an object is present. This object is pulling towards right with certain amount of force. Obviously, the object would get acceleration. The object would get acceleration because of the application of force, right? Now, if the same amount of magnitude we are applying on the object for the other side, then is the object can able to move? No, because the application of force remains same on the two sides. So object remains at rest position. In this case, there is no acceleration for the object. It says that even some set of forces are acting on the object, but the object remains at rest position. The object remains at rest position. This is what is known as equilibrium. This is what is known as equilibrium, right? Then next one is, let us see some numericals. Let us see some numericals over the concept we have covered. Now first point is the breaking strength of the string connected ball and the block B is 175 newtons. That means, see here, it is exerting 175 newtons. As I told you here, set of forces, sorry, tension force acts away from the point of contact. And here I have to draw free body diagram for block B. Let us draw free body diagram for block B. Of course here is also point of contact is present, so tension force will act like this also. But here I would like to represent free body diagram for only block B. So for block B, normal force will exert in the upward direction due to the surface, and mg will act in the downward direction due to earth. And the students will get a doubt here. Sir, simultaneously, block B will also exert normal force on the floor. On the floor. But you must remember one most important concept is, while we are drawing, while we are drawing free body diagram, free body diagram, we have to represent set of forces acting on the object, on the object, not by the object, not by the object. See the force which you said, the block B is exerting on the surface, that is force by the surface, which we can never consider as a force while we are drawing free body diagram. I hope I am very clear. So what are the set of forces are acting here? So one more tension force, let us say it is T1, otherwise T2. This is I am considering as T1, right? T1 and T2. And here for our problem, of course, see this one, and for solving I am removing this one. Solving the problem I am removing this one, right? See here, the next point is set of the forces acting on B. Forces forces on B along y axis. See, and we have to consider this as the origin for this particular block, and from origin upward direction I consider as positive, downward direction I consider as negative, rightward direction I consider as positive, leftward direction I consider as negative, right? So for n positive minus mg is equals to, and okay, before that, by using Newton's second law, second law, set of all the forces acting on the object makes my object to attain an acceleration a. Now, what are the set of forces acting on my object in vertical direction? N minus mg is equals to, but object remains at rest position. It is neither moving in the upward direction nor moving in the downward direction, right? So, n is equals to mg. N is equals to mg. This is the normal force exerting on block in the vertical direction. And second one is along x-axis. Along x-axis. See again, along x-axis means the set of all the forces acting is equals to MA along x-axis also, right? And here T2 acting in the rightward direction and minus 1 to 175 acting in the leftward direction mass, but the object remains at rest position, so it is not getting any acceleration. Obviously ax is equals to 0. Then we can consider T2 is equals to 175 Newton. T2 is equals to 175 Newton. Now, next part of the question is here. This can be, suppose, let us assume only T, because this is T2, this is T1. Let us assume it is only T, right? Otherwise, I could draw one more time the same diagram because it is very small, right? See, block B. Now I got T2 is equals to 175 Newton, 175 Newton, and block A, this is 30 degrees, 30 degrees. Now this will be, I considered T, T2, T1, T1. Now T, I can consider that tension as a vector force because it is a force. That vector I can resolve into two components, T cos 30, T sin 30, and this direction is T2, because remember again one most important point is single thread contains a single tension only. A single thread, for every single thread contains single force only. That means here to here only single thread. So the amount of tension is remains T2 forever. Forever. Here T1, here T2, here T3, here T4. It is not possible. Single thread means it should possess only single tension value, single tension value. Now the next point is, see here, along x-axis, along x-axis, sigma fx is equals to max. Now, rightward direction I am considering as positive for this particular point. For this particular point, t cos 30 minus t2 is equals to, this particular point is having, suppose, m dash or m1 as the mass, but the acceleration of the point remains 0. Then this one, t cos 30 is equals to t2, and the value of t2 is equals to 175 degrees, which I have shown you, and this will be root 3 by 2, 175, and tension value is equals to 350 by root 3 newtons. This is the amount of tension present at this point. So this tension present in this string is 350 by root 3. 350 by root 3. Now I want to find T1 value. Now I want to find T1 value. Find the magnitude of weight of the block A. Now, see, block is present. Here T is present. Here T cos 30. This is T sin 30. And here T1 is present. Here T1 is present. So, here mg is present. Right? Now, and for point P, point P, for point P, sigma fx is fy is equals to may, and upward direction t sin 30 is equals to downward direction, or otherwise minus t1 is equals to m0, because the point is not moving either upward or downward direction. Then t1 by 2 is equals to t1. Now t1 is equals to 1 by 2 of 350 by root 3. That is what is t value, just now I shown you. Then t1 is equals to 175 by root 3 newton. This is what is t1 value. This is what is t1 value. Now here, for block A, applying Newton's second law for block A in vertical direction, sigma fy is equals to may. Now set of the forces acting on block A in vertical direction is, T1 is acting in the upward direction, mg is acting in the downward direction. Now T1 mg m0, because block A is also not having any acceleration, right? Then T1 is equals to, mg means weight is equals to 0. So T1 is equals to weight. That weight value is equals to 175 by root 3 newtons. This is the weight of the block A. This is the weight of the block A. Right? Now, let us see for the second question. A cylinder of weight W, a cylinder of weight W is resting on two inclined planes. A cylinder of weight W is resting on two inclined planes forming V groove as shown in figure. Ignore friction everywhere. Draw its free body diagram of the surface. Drawing free body diagram means, see here, this is the sphere, and as I told you, here one normal force will exert, here one normal force will exert, and angle remains the same. Angle remains the same means, here with respect to this will be 60 degrees, this will be 60 degrees, right? See, this is 60, this is 60, this is 60 means this one is also 60, if it is 60 means this one is also 60, right? And here the sphere is in contact with two places, it is having contact at two places, and so we can write two normal forces. Free body diagram has been completed. And understand, simultaneously the sphere is also exerting equal amount of normal force on the surfaces, but we are considering only the set of forces acting on the object while we are drawing free body diagram, not by the object. So, right? That's why we are considering only normal forces due to surface acting on the sphere. Here I am representing. Clear? Now calculate the normal reactions between the cylinder and two inclined walls. Right? Now this is can be resolved into two components. Now it is 60 means it will be 60. Then it will be n cos 60, and it is 60 means obviously it will be 60, and it will be 60. See, it will be 60, then this will be n cos 60, and earth is always acting a weight mg towards the center of the earth, and obviously here they represented directly weight only, they are representing directly weight w, right? So they are asking us to find normal force. That's why here sigma Fy, set of all the forces acting on the y axis, is equals to, see here this is x axis, this is y axis. Now I am applying on y axis what are the set of forces are representing in the upward direction, that is n cos 60 plus n cos 60 is equals to mass, sorry, and mg is acting in the downward direction on the same y axis, minus w is equals to m into acceleration is 0, right? Now 2n cos 60 minus w is equals to 0, right? Then 2n 1 by 2 is equals to w, these two will get cancelled. Then normal force exerted on the surfaces, on the sphere due to surfaces, is equals to the weight of the object, weight of the object, right? Then third one is, and see here the concept which we were covered is obviously different than the problems which we are doing now. Here I am discussing critical problems for you, make you to be more comfortable with the easy problems, you can understand easily and solve practice easily. That's why I am discussing hard, little bit hard problems here, and I am trying to represent each and every single concept in a clear and crystal way, clearly crystal way, in a loose language I am giving this subject. I hope everyone has to understand the subject and everyone has to learn in a proper way to get the perfect knowledge in the physics subject. That if you are really attending my classes regularly, this will definitely help you a lot. And once you are going thoroughly with my classes, you can definitely message, let me know that how you feel, how you are feeling also, let me know, right? Then next one is, see here, a sphere is present, a sphere is present like this, and it is making an angle 30 degrees, 30 degrees. Its weight is 50, sorry, its mass is 50 kg, 50 kg mass is present. Vertical wall B, calculate the contact forces at A and B, right? This is the point B, this is the point A, and here normal force is acting on the sphere which I am considering as a free body diagram, and here let us, this is n1 and let it is n2, n2, right? And apart of these two forces, only one more force is acting, that is weight w or mg, weight is also acting, mg. Now here this is actually, you can consider making an angle 30 degrees here, making an angle 30 degrees here. Now if it is 30 degree means obviously it is also 30. See, very careful here, this angle between these two lines is 90 degrees, so this will be 30 means it will be 60, and again consider the angle between these two is 90 degrees. So if it is 60 means it will be 30. This is the procedure for understanding how we can represent angle values between various vectors. So it is 30, that means n1 cos 30 vertically acting, right, and n1 sin 30 is acting horizontally. These are the two resolving components of the n1, right. Now sigma f x is equals to max. This is about Newton. Sorry, this is Newton's second law about x-axis. Now sigma fx is equals to set of forces acting on the x-axis. N1 sine 30 and n2 is also acting in the leftward direction. N2 is equals to m a x. Ax value is 0 here, 0 here, because the object is at rest position. It is not moving neither leftward or rightward along the x-axis. So it can says that n1 by 2 is equals to n2. Let it be equation number 1. Let it be equation number 1. Now similarly, let us try to write sigma fy is equals to ma by. So what are the forces acting on the y-axis? On the y-axis means this is x-axis, this is y-axis. That means n1 cos 30 minus mg is equals to m into 0. Now n1 is equals to n1 root 3 by 2, mass is 50 kg, into acceleration due to gravity is 10 is equals to 0, 0. Here I am not representing g as minus 10 because already we are representing in the downward direction only, in the downward direction only. That's why here I am representing directly minus, right? Then n1 root 3 by 2 is equals to 500. Then n1 is equals to 1000 by root 3 newtons. 1000 by root 3 newtons. Clear? And next one is n2 is equals to n1 by 2. So n2 is equals to n1 by 2 means 500 by root 3 newtons. And these are the two forces they are asking us to find. Clear? Now, next one is a man of mass m is hanging cabin of mass m is able to keep himself and cabin at equilibrium. Draw the forces acting on the man and cabin. Here the man, suppose he is the man holding a thread, holding a thread. And what are the different forces acting on the man? Number one, normal force due to floor and weight of the man because of the earth, and tension force is also exerting on the man in the upward direction. Tension force is also acting on the man in the upward direction, and he is not moving neither up, neither rightward or leftward, so no need to consider fx values. Similarly, forces acting on the cabin also. Forces acting on the cabin means the cabin is holding T, and one more thread is like this T, and normal force due to man N, and weight of the cabin is mg. Mg. Right? Now let us say here sigma f is equals to may about y axis, t plus n is equals to or minus mg is equals to 0 because a is not moving in any direction. Then t plus n is equals to mg, right? Or one point here, tension is not acting on the man. It is a force acting by the man on the thread. So forget about finding or representing tension. So n is equals to mg. Normal force acting by the floor on the man is equals to mg. Now similarly, calculate the force applied by man on the rope. 2t, right, and a normal reaction of the floor acting on the man. This is the normal reaction acting on the man by the floor. first point. And tension they are asking. So for this one, sigma f is equals to ma by now 2t minus n minus mg is equals to m into 0, and 2t n values small mg, capital mg is equals to 0, then 2t is equals to m plus m into g, t is equals to m plus m into g by 2. This is the tension force applied by man on the rope. This is what is our today's class, right? And next point is for our daily worksheets and weekend examination papers, better to follow my Telegram channel, Physics with Jagan sir. Again and again, I'm saying these are the most conceptual understanding I'm trying to give you, and giving you conceptual understanding is the first point. And second point, based on the same concept, I am giving you some critical, important, and logical examples, numericals, which will definitely helps you in understanding the subject in the best way, and you better to practice a lot. That will helps you a lot in your final examination. Have a great day. Take care. Bye bye.